G'day, my name is Damien Dry and I work at the Department of State Growth in the Project Services as a Project Manager. Now today I'd like to share with you computing watersheds within our, road reserve, because that's the focus I'm using on, but you can use it for a variety of things related to streams and whatnot. So, as you can see, I've opened up ArcGIS. I've got ArcMap open. Now, the first thing I need to do is make sure I've got a few of these selected. So, if I right-click on the toolbar, I'm going to need Draw. I'm going to need Spatial Services Group Toolbar, and that should probably be enough. So, the Spatial Services toolbar is this one. The first button I'll need is the Layer Manager. Now, I'll bring in a few different layers. Now, the first thing I'll need is the road. Then I might bring in some contours. 5 meter intervals seems alright. That's the best we've got. And I might also bring in the ortho photo. So I've got a bit of a feel. Statewide ortho photo. That'll work. Here we go. Populating these 3 layers. I'll turn those off so I can load the map a little bit quicker. And the road that I'm looking at today is on the East Derwent Highway. It's not on the East Derwent Highway. It's on Grass Tree Hill, which is just on the edge of the East Derwent Highway. So Tasman Bridge, East Derwent Highway, Grass Tree Hill. Okay, so this is where I'm at, around this area. So the project I'm looking at starts at Shaw's Corner and goes all the way around to Sugarloaf Road. So if I turn on the contours, I can get a feel of the terrain in the surrounding area. Oh, it looks alright. Now, the first thing I'll need to do in this computation is draw the extent of where I'm going to compute these watersheds. So I might just draw a big box that tries to capture quite a bit of it. Not too much, otherwise it'll take a long time to compute, and too little, and you won't get an accurate reflection. So I'll make sure my draw tool's got the extent. Yep, that looks like it captures most of it. What I'll need to now do is convert this graphic that I've just drawn, this rectangle, into a feature. So polygraphic, same coordinates as data frame, and everything looks good. Add the exported data to the map. Yes, that's what we want. And I'll turn it off, and the one that I've got there, I can just delete it. So select it, delete. And I'll turn it back on, that's it there. Now what I'm going to do next is clip these contour lines just so I can find that area within here, because I don't need anything else. So it's a geo process. I need to clip, I'll need an input, a clip feature, and then I'll get an output. So our input will be these contours, our clip feature will be this extent that we've just done, and then hopefully we'll get an output just within there. So input, contours at 5 meters, clip feature, converted graphics, and I'll make sure I save it within my folder, my Grass Tree Hill, and I'll call it clipped contour 5 meter. Should be alright. There we go. Okay, it's clipping, and clipped. So it gives me a bit of a rundown of the session, how long it took. It was successful. 703. Okay, great. Now I'll turn off the statewide contour layer, and now I've just got that layer, the clipped layer that I had before. So the next step in this is to use some of the toolboxes that ArcGIS provides to be able to start to do some hydrology modeling. So the first thing I need to do before I can start doing that is I need to make sure that I turn this contour layer into a raster, so that I turn the topography of the land into a raster. So I need to use the Arc toolbox. I'll throw it on the side if I can. I'm going to use the spatial analyst, you may want to be careful when you customize those extensions. You need to make sure that you've got spatial analyst clicked, and there is only one license, so only one person can do this at a time. So spatial analyst, I'll go down to interpolate. I'll turn the topography into a raster. So I need to select the input feature, which will be this clipped contour 5 meters. The field that we'll get the raster from needs to be the elevation data. So I need to select the elevation column that we're going to source the data from. Now, as you can see, I've got output surface raster. Where am I going to save this? I'll save it to here. I'll call it topo underscore to raster, or R for raster, and I might change this output cell size to about 5 just to give us a little bit more accurate information. Output extent to the clipped contour, I could also use converted graphic. Both of those are the same, and that looks like it's alright. So I'll go ahead and click OK. Now you can see down here that the topo to raster is slowly computing. Now it may take a little bit of time depending on the level of detail that you've put forward, or you've selected as an option. I selected 5. You can go down to as low as 1. I've even tried 0.5, but generally a few integers is fairly good in terms of quality. Given the extent of what we're looking at, this is probably, I don't know, maybe 10 k's across. It's probably not recommended to go into too detail. So here we go, the top of, well, the raster has been created, and if I turn off these contour lines, you get a little bit of a feel. So obviously the pinkier colours, that's the peak, then we go down to the base, which is the green. So anyway, you can see the road kind of snakes through some of this green here. Okay, so there we go. I can start to do some hydrology models. So in the spatial analysis toolbox, I'll go to fill. Now fill is one of the things that you want to use just to make sure that the raster you've created doesn't have any dips where water may pool during the calculations unexpectedly, and which isn't the case in real life. So my input surface is this raster image we've just created. I'll make sure I save it. Fill underscore R raster, save, go ahead. Fill down here, it's computing. That's what it looks like. Looks good. The next thing I'll need to do is to establish the flow direction. So for each of these cells, which is 5 meters wide, where will water, if it pools on there, where will that flow to? So I'll double click on flow direction. I'll bring in that fill, one that we just created. I'll make sure I save it to this grass tree hill file. Flow direction underscore raster, let's call it. Okay, let's save. And here we go. So all these colors give us an indication of the flow direction, where it's flowing. Not flowing anywhere, that's the dam there, but it's flowing in different directions. So I need to see where this flow direction, where it'll accumulate. So if I double click on flow accumulation, my input raster will be this flow direction, and I'll make sure I save it. Flow accumulation, accumulation of the raster. Save. Okay, let's fire ahead. I'll turn off that layer, and there we go. We get a bit of a feel of what it looks like. Now I'll turn off, so you can see. So the problem is we've got essentially just, I don't know, one line with 1 or 2 offshoots. Now the problem is the black cells are represented as 0, and white cells are represented as, what's that? 750,000 or more, 870,000. So I need to do a little bit of a computation to bring out those other ones. So what I can do is I'll use map algebra. If I open this up, I've got a raster calculator, and I'll take the log base 10 of this flow accumulation that we just created, and I'll make sure I save it. flow accumulation log 10 underscore raster save. Oh, I've got an error. Now my name is too long, so I might just delete a few characters. There we go, looks good. Oh, now we have almost too much information. We've got it saying flows here, this way, everywhere, because we're bringing up heaps of information. Now I'll just identify some of these values that we have on this cell. I had this issue before. Nope. I need to just make sure. I just want to select, I suppose, one element just to get a feel for where it is at that point. Turn off the converted graphics, see if that makes a difference. Try to remember that for next time. So it looks like a lot of these values are around that kind of 2 figure, less than 2. So what I might do is I might see if I can filter those out through another math algebra. So I'll go the raster calculator, I'll go conditional. So what I might do now is conditional. I'll say for the flow accumulation log 10, where it is greater than or equal to, let's say 2.5, just to be safe. Just show me where it is greater, show me that. So essentially just get rid of anything that's less than 2.5. Okay, let's try that. Let me save log 10 log, let's say underscore greater than 2. Hopefully not too many figures. Okay, 2. There we go. Too easy. Okay, rest out. I've got an error. What's happened? String something. I haven't put it in correctly. Could not save output format good. Okay, let me try it again. I think the name might have just stuffed it up here a little bit. So condition log greater than or equal to, let's say 2.5, and bring me back that. Okay. I'll just got flow accumulation 2. Here we go. Okay, we've got it to work this time. So looks good, looks promising. Not sure what's happened. I appear to have lost it. Here we go. Now I'll turn off the log 10, and now I just get the log 2. Now I'll change some of the color. So if I double click on the symbology, I'll turn it to a hot and cold map. So there we are. I'll just play around a little bit with it. So here we go. So we can see, obviously the darker colors are where streams go, or where there will be a stream. The lighter colors are what feeds into a stream. So you can see, get a little bit of indication. If we throw on some of this clip contour that we had, you can get a bit of a feel for where some of it comes out. I'll just change this to 1 so you can see it a little bit better. Yeah. Okay. Let me turn on the road now, so you can see now that there's several sections on this road where water would appear to be coming in. Now, well, where streams would be forming. So here's one, flows down here, another here, quite a big one here. So these points are points that I need to consider, and consider how drainage is going to be accounted for at those spots. So that's basically a rough background on how to use ArcGIS and some of the list data to then create a little bit of a hydrology model of some of the projects that you're working on. Hope you've enjoyed. Thanks a lot. Bye.